Imagine a camera so massive it could swallow a car whole, and then imagine another one so tiny it could hide inside a grain of rice. Both of these things actually exist. Right now, somewhere in the world, engineers have built cameras that defy every single limit we thought photography had. We're not talking about slightly bigger or slightly smaller than your average DSLR. We're talking about machines the size of buildings and sensors smaller than the tip of your fingernail. And today, we're putting them face to face in the most extreme camera showdown ever made. From the giants that took decades and billions of dollars to construct, to the microscopic marvels engineered at the very edge of human technology, get ready, because your idea of what a camera even is about to be completely shattered. Stay with us, because number one on both ends of this list will genuinely blow your mind. Let's start big. Let's start really, really big. Coming in at number 5 on our biggest cameras list is the Large Binocular Telescope, or LBT, sitting on top of Mount Graham in Arizona, USA. Now, technically, astronomers call it a telescope, but make no mistake, this thing is a camera. It captures images of the universe using 2 enormous mirrors, each one 8.4 meters across, mounted side by side on a single rotating structure. The whole instrument weighs around 580 metric tons and stands as tall as an 8-story building. It was built through a collaboration between American, Italian, and German institutions, and it saw first light in 2004. The LBT can capture images with a resolution that would let you read a newspaper from 100 kilometers away. Each of its mirrors took years to cast, grind, and polish to near perfect smoothness inside a specially designed rotating oven at the University of Arizona's Steward Observatory Mirror Lab. This is not a camera you carry around. This is a camera you build a mountain around.
Number 4 is the Subaru Telescope's Hyper Supreme Cam, located at the Mauna Kea Observatory in Hawaii. The telescope itself has an 8.2-meter primary mirror, and the camera attached to it, the Hyper Supreme Cam, is the size of a small car, weighing about 3 tons. It was developed by the National Astronomical Observatory of Japan and took over a decade of engineering work before it began full science operations in 2014. What makes this camera extraordinary is its field of view. It can photograph an area of sky 1.5 degrees wide in a single shot, which is roughly 9 times the area of the full moon. It uses 116 individual image sensors packed together to produce images of 870 megapixels. A single image from this camera contains so much data that it would take thousands of your home computer screens to display it at full resolution. Japan built this to map the entire universe, and it's doing exactly that. Number 3 takes us underground. Or rather, it takes us to a camera so large that the underground was literally carved out to hold it. This is the IceCube Neutrino Observatory, located at the South Pole, Antarctica. IceCube is a camera in the most radical sense of the word. It doesn't photograph light, it photographs particles called neutrinos, the most ghostly and elusive particles in the known universe. The detector is buried between 1,450 and 2,450 meters beneath the Antarctic ice sheet and consists of 5,160 optical sensors spread across a cubic kilometer of ice. 1 cubic kilometer. The entire thing was built by the University of Wisconsin-Madison with support from the National Science Foundation, and construction was completed in December 2010 after 7 years of drilling into one of the most remote and hostile environments on Earth. The sensors were lowered into holes melted through the ice using a specialized hot water drill, and then the ice refroze around them permanently. This camera will never be moved. It is frozen into the planet itself. Number 2 on our biggest cameras list is the Dark Energy Camera, known as DCAM, mounted on the Victor M. Blanco telescope at the Cerro Tololo Inter-American Observatory in Chile. The camera alone weighs 4 tons, measures about the size of a phone booth, and houses 74 individual CCD sensors that together produce images of 570 megapixels. It was built by the Fermi National Accelerator Laboratory in the United States, with contributions from institutions across the UK, Spain, Brazil, Germany, and Switzerland. DCAM saw first light in September 2012, and it was designed specifically to study dark energy, the mysterious force that is accelerating the expansion of the universe. Over 5 years of operation, it photographed over 300 million galaxies, capturing light that had been traveling through space for 8 billion years before landing on its sensors. It operates at negative 100 degrees Celsius to reduce electronic noise, and each image it takes covers an area of sky 2.2 degrees wide. This camera is hunting for the secret of why the universe exists the way it does. And the number one biggest camera ever built, there is nothing else on Earth even close to this, is the Legacy Survey of Space and Time camera, called the LSST camera, built for the Vera C. Rubin Observatory currently under construction on Cerro Pachón in Chile. This camera is officially the largest digital camera ever constructed for astronomy, and arguably the largest camera of any kind ever built for scientific use. It is 3 meters long, weighs 2,800 kilograms, and its focal plane, the part that actually captures the image, is the size of a small dining table, measuring 64 centimeters across. It contains 189 individual CCD sensors, and together they produce images of 3,200 megapixels, 3.2 gigapixels in a single shot. Every image it takes would require 1,500 high-definition television screens to display at full resolution. It was built at the SLAC National Accelerator Laboratory in California, a project that took over 2 decades of planning, design, and engineering, with a total project cost exceeding $700 million. In 2020, the camera achieved first light in the laboratory, and once the Rubin Observatory is fully operational, it will photograph the entire visible southern sky every 3 nights for 10 years, cataloging tens of billions of stars, galaxies, and cosmic objects. This is the most powerful camera ever assembled by human hands.
Now let's flip everything completely. At number 5 on our smallest cameras list, we have the OmniVision OV6948, a commercial medical imaging sensor that held the Guinness World Record for the world's smallest commercially available image sensor. Made by OmniVision Technologies, a company based in Santa Clara, California, this sensor measures just 0.575 millimeters by 0.575 millimeters, smaller than a grain of coarse salt. It was announced in 2019 and was specifically designed for use inside single-use endoscopes and other medical imaging tools that need to navigate inside the human body through extremely narrow passages. Despite its microscopic size, it captures images in full color at a resolution of 200 by 200 pixels, which is enough for a doctor to clearly see tissue and diagnose conditions inside blood vessels, bile ducts, and other tight anatomical spaces. It was manufactured in Taiwan and packaged into a module that is just 1.0 millimeter wide, thin enough to fit inside a needle. This camera saved lives the year it was released, and it has been saving them ever since. Number 4 is the world's smallest spy camera ever put into commercial production, the AMS Osram CMV2000, used inside a device known as the Metegis Ultra Mini Endoscope. But the version we're focusing on here is the standalone chip used by engineers and developers worldwide. Actually, let's talk about the pinhole spy cameras built around sensors like the Pixum and similar chips. But the real star of ultra-miniature cameras for surveillance and consumer electronics is the camera module inside devices like the OV2640, a sensor originally developed by OmniVision and measuring approximately 2.4 millimeters by 2.4 millimeters. It was first introduced in the early 2000s and became one of the most widely used tiny camera sensors in the world, embedded inside baby monitors, smartphones, laptops, and security systems across dozens of countries. It captures images at 2 megapixels and supports video output. Billions of these sensors have been manufactured in facilities across Asia, and there's a very good chance that a camera based on this sensor has been inside your home at some point without you ever noticing how impossibly small it is. Number 3 goes somewhere that no human eye could ever go without help, inside the body. This is the Given Imaging PillCam, first developed by the Israeli company Given Imaging, which is now part of Medtronic, one of the world's largest medical device companies. The PillCam is a swallowable capsule, roughly the size and shape of a large vitamin pill, measuring 11 millimeters wide and 26 millimeters long. And inside that capsule is a complete, functioning camera system. It was approved by the U.S. Food and Drug Administration in 2001, making it the first capsule endoscopy device ever cleared for medical use in the world. The camera inside takes between 2 and 6 images per second as it travels through the digestive system, transmitting the photos wirelessly to a recorder worn on the patient's belt. By the time it exits the body naturally, around 8 hours later, it has taken up to 60,000 images of the intestinal walls. It requires no sedation, no tubes, and no discomfort beyond swallowing a pill. The camera inside uses CMOS sensor technology and LED lighting,
all packed into something you can hold between 2 fingers. Number 2 is something straight out of science fiction, and it was built not by a giant corporation, but by researchers at the University of Stuttgart in Germany. In 2016, a team of scientists 3D printed a fully functional multi-lens camera directly onto the tip of an optical fiber. The entire camera system, lenses included, is just 0.1 millimeters across. That is smaller than the diameter of a human hair. The camera uses a stack of 3 lenses, each one printed in a polymer material using 2-photon lithography, a 3D printing technique that works at the nanoscale. The whole fabrication process takes just a few hours. The resulting camera can capture images with a field of view of around 70 degrees and was designed to be guided through the narrowest blood vessels and nerve fibers in the human body for medical imaging. The research was published in the journal Nature Photonics and immediately drew worldwide attention from the medical, engineering, and photography communities. This camera is so small that the lens itself is invisible to the naked eye, and yet it produces recognizable, usable images. That is not a concept. That is a real camera that exists right now.
And the number 1 smallest camera ever created, something so mind-bendingly tiny that it challenges the very definition of what a camera is, was developed by researchers at Princeton University and the University of Washington and published in November 2021. They built a camera the size of a grain of salt. The entire device measures just 0.5 millimeter across, 0.5 millimeters, and yet it can produce full-color images with a field of view of 70 degrees and a quality that rivals lenses thousands of times its size. The secret is a technology called a metasurface, a flat optical surface covered in 1.6 million tiny cylindrical posts, each one smaller than a human hair, that manipulate light in ways that traditional lenses do using curved glass. Instead of bending light the old-fashioned way, the metasurface redirects it computationally, with artificial intelligence processing the raw sensor data into a clear, focused image. The research was funded by the US government and took years of nanofabrication work to perfect. The potential applications include medical devices that crawl through individual neurons, robots with full vision systems the size of insects, and surfaces that are entirely covered in invisible cameras. This camera is not just the smallest ever made, it may be the most consequential invention in photography since the first photograph was taken in 1826.